Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to Math Solver 1117. Today we are going to solve mixed exercise chapter 7 algebraic methods from pure maths A level question number 16, 17 and 18 in very easy and simple way. If you are new, subscribe Math Solver 1117 and also hit the bell icon to get notification for all upcoming videos. Now we will start today's lecture. Now the question number 16 is use completing square to prove n square minus 8n plus 20 is positive for all values of n. So we will solve this by completing square method. Now the function is n square minus 8n plus 20. We will solve this by completing square such that n square is the square of n and minus 8n can be write as 2 into n into 4. Its mean we will add and subtract the square of 4. So plus 4 square plus 20 minus 4 square. So this will become the square of n minus 4 whole square and plus 20 minus 16. So n minus 4 whole square plus 4. So we will say the minimum value is 4. So n square minus 8n plus 20 is always positive. Now we will solve question number 17. Now the question number 7 is prove that quadrilateral A11 B32 C40 and D2 minus 1 is a square. So we will solve this by finding the gradient of all the lines such that first of all we will draw a quadrilateral shape like a square. All four sides are of equal length. This point is A, this point is B, this point is C and this point is D. So we will prove this that this is a square. For this purpose, first of all find the gradient of line AB. So the gradient of AB will be equal to the 2 minus 1. Gradient is y2 minus y1 by x2 minus x1. So 2 minus 1 and 3 minus 1. So this is equal to the 2 minus 1 is 1, 3 minus 1 is 2. So 1 by 2. Now the gradient of B and C. So this will be equal to the 0 minus 2, 4 minus 3. So this is equal to minus 2 and 4 minus 3 is 1. Now the gradient of CD, this will be equal to minus 1 minus 0 and 2 minus 4. So minus 1 minus 0 is minus 1 and 2 minus 4 is minus 2. So it will become 1 by 2. Now the gradient of the line AD will be, you will say gradient of AD which will be equal to the minus 1 and 2 minus 1. So minus 1 into minus 1 will be the minus 2 and 2 minus 1 is 1. So this is equal to the minus 2. Now we see that AB and BC all are the perpendicular. So we will find the distance of this. So now the distance of AB will be the, here we find the distance of each. Now distance of AB will be equal to the square root of B minus 1. B into A will be 2 minus 1 square. So 2 minus 1 square is 1 plus 3 minus 1 2 square. So this will equal to 1 square plus 2 square, which is equal to the 5. So square root of 5. Now the distance of BC will be equal to the C minus B means 0 minus 2. 0 minus 2 means minus 2 square, which is 4, plus 4 minus 3, which is equal to 1. 1 square is 1. So this is also equal to the square root of 5. Now the distance of CD, which is equal to the D minus C. Minus 1 minus 0 is minus 1 square, which is 1, and 2 minus 4 is minus 2. Minus 2 square is 4. So this is equal to the square root of 5. Now we will find the distance of AD, which will be equal to the minus 1 minus 1 minus 2. Minus 2 square is 4 plus 2 minus 1 is 1. 1 square is 1. So this is also equal to the square root of 5. Now all the distances are equal. It means that ABCD is a square. Because the distance of AB, BC, AD, all distances are the same. So we will say that this shape is a square. Now question number 18. Now the question number 18 is prove that the sum of two consecutive positive odd number less than 10 gives an even number. So two consecutive odd number like 1 plus 3, which is equal to 4, and this is a even. Then 3 plus 5, which is equal to 8, and this is also even. Then 5 plus 7, which is equal to 12. So this is also even. And the 7 plus 9, which is equal to the 16, and this is also a even number. So we have proved that the sum of two consecutive positive odd numbers is always even number. I hope you understand all the questions we have solved in this video. In the next video, we will solve the remaining question of this exercise. Stay tuned. Allah Hafiz.